All right, so today, now that we've talked about exponential functions, had our quiz over exponential functions, we finally get into logarithms, what they are and why we need them. Okay, so starting with exponential functions, we kind of get a need from that. So if we're trying to solve this equation, number one, it says 2 to what power, 2 to the x equals 8. And so you're thinking, okay, 2 to what power equals 8? Well, 2 to the third equals 8. 2 to the third equals 8. So x has to be 3. All right. Going with number two, we're saying 3 to what power equals 9? Well, 3 squared equals 9. So x has to be 2. Okay, we're just using our logic in that way. Coming to number three, we have 5 to what power equals 1/5. Well, we know that if we raise 5 to the negative first power, that's going to do a flip, right? Instead of the 5 being up top, it's going to go down to the denominator. So x has to be -1 there. What about number four? 8 to the x, 8 to what power equals 1? Well, 8 to the 0 power, because anything to the 0 power equals 1. So x is 0. All right, I think number five, a little tricky. 4 to what power equals 2? It's harder to go from a big number to a smaller number like that. But in order to do that, it's 4 to the 1/2 equals 2. Because remember, 1/2 power is the same as the square root of 4. So that equals 2. So my x is 1/2. When we're going from something big to something small, we're usually doing it with a fractional power. Okay. And then the last one here, it says 2 to what power equals 12? And this one is where we need logarithms. Um, because I can't think of a number, and it's not just because I can't think of it, it's some crazy weird decimal number um, to do this one. Okay. When we say 2 to what power? Well, I know 2 cubed is 8. I know 2 to the fourth is 16. So it's somewhere between 3 and 4. If I do like 2 to the 3.5, like in the calculator, get 11.31. I'm trying to figure out 2 to what power is going to give me 12. We could guess like 2 to the 3.6. 2 to the 3.6 gives me like 12.13. So it's somewhere between, 3.5 and 3.6. We'd have to kind of keep guessing and trying to go there. So this is why we need logarithms, to be able to solve for the x when it's not a whole number that we're familiar with, or even a fraction that we're familiar with. Okay. So any exponential function can be written as a logarithmic function. And so here, logarithms, it says if we have something that is like b to the x equals y. So for that example there, 2 to the x equals 12. We can rewrite that as a logarithm to solve for the x. So this will be the log base 2 of 12 equals x. And so like I just read that, it's log base b of y. So log base 2 of 12 equals x. Okay. So ones that we do know, like since 2 cubed is 8, I know log base 2 of 8 is 3. So oftentimes we hear a logarithm being described as, oh, it's just the exponent. Because what we're really doing with a logarithm is like solving for the exponent. The x value that was up in the exponent is now like the answer. So it's a way to get the exponent kind of down to the regular level of math. Okay, so we're going to use logarithms to rewrite exponentials. and eventually then to solve for something that's in an exponent. So this first page, we're just rewriting. So just to understand this logarithm notation, that anytime here 2 to the 5th equals 32, that means I have log base 2 of 32 equals 5. Okay, so just rewriting it. The base, we always say the base is 2. Well, here the base is 2. Log base 2 of 32 is 5. Your answer is the exponent. Okay, so going the other way, if I have log base 12 of 144, log base 12 of 144, that equals 2. Well, that is equivalent to saying 12 squared is 144. Like we can go both directions. Okay, if 4 to the 0 equals 1, that means log base 4 of 1 equals 0. The base stays the same, but we're kind of switching the exponent and the answer when we go to the logarithmic form. Okay, this last one says log base 16 of 4. So we have 16 as our base to the 0.5 power is 4. Just rewriting it, saying really 16 to the 1/2 power, square root of 16 is 4. Like, yep, that checks out. Okay. Down this second row, we have some little bit more complicated, but still works. Here, if we have 4 to the 3/2 power equals 8, that's saying log base 4 of 8 is 3/2. Rewriting so far. We're eventually going to have to solve these, but for now, just rewriting. Okay. This guy, log base 6, because the 6 is the base, of 1 over 36 is -2. We see that, -2 means we're going to flip it and square it so that we get that 1/36 up in the exponent. The log just switches it. This next one is kind of doing the opposite. It's saying instead of the log, we want to go to exponential. So 6 to the -3rd power is going to be 1 over 216. And then our last one, 8, always the base here is the base here. 8 to the 1/3 power, or the cube root of 8, is 2. Okay, so just rewriting. And so in some of those, we saw one of these rules up here, this guy. We know that anything to the 0 power is 1. Like that's anything to the 0 power is 1. Well, the rule that we have for logarithms then is the log base b of 1 is going to be 0. That like the log base 17 of 1 is 0, because that really means 17 to the 0 power equals 1. Okay, or log base 5 of 1 equals 0, because 5 to the 0 power equals 1. So we have this rule, log base anything of 1 is 0. And again, that's because anything to the 0 power equals 1. Now it does say up here, good thing to mention, b has to be a positive number. Okay, we are never going to work with a negative base at this point in time in algebra 2. And in logarithms in general, we kind of won't, but our base has to be positive. Okay. Also, the thing we take the logarithm of is going to be positive. We can have a negative exponent, but we can't have a negative answer if we have a non-negative base. Okay. And then this one, log base b of b equals 1. I don't know if we saw any examples of it, but it'd be about like log base 4 of 4 equals 1. Because what we're saying is 4 to the 1st power equals 4. So log base 17 of 17 equals 1. 17 to the 1st power equals 17. So this is like another rule. If your base and your argument, the thing you're taking the logarithm of, are the same, you're going to get 1 as your answer. Okay. On the back, we're going to actually evaluate logarithms. So this is saying, what does it equal? On the front, we rewrote them. Well, now we actually have to solve them. And a lot of times, When we don't have a calculator, it says without a calculator, try and do this. We're thinking about it as an exponent. So when I have log base 4 of 64, what I'm really saying is 4 to what power is 64? Like that's what I want to think about when I'm doing this problem. 4 to what power is 64? And if you still have your exponent little cheat sheet, our little orange sheet, that could be helpful on this, but 4 cubed is 64. So that cubed, that's actually our answer. That log base 4 of 64 is 3. Okay. This next one, we're saying 36 to what power is 6? Because the 36 is the base. So we're saying 36 to what power is 6? Well, in order to go from a big number to a small number, we're usually doing a fractional thing, a square root, a cube root, something like that. And I know 36, like the square root of 36 is 6. So that's really 36 to the 1/2 power equals 6. So that 1/2 is the answer to our logarithm. Whatever we're saying is the exponent, that's what we put as the answer to our logarithm. All right, number 9 looks a little funny. It's saying 5 to what power is 0.2? And this is where we do need to know a bit about our math stuff. That 0.2 is really 1/5. Okay, so it looks like it's not necessarily a fraction, but it is. 5 to what power is 1/5? Well, our little question mark is going to be 5 to the -1 power is how we get to 1/5. So -1 is our answer there. And the way these get, I guess, harder, the ones that we can do, is they just become things we have to think more about. Um, for example, log base 1/5 of 125. So we're saying 1/5 to what power equals 125? Well, that is a little bit tricky, right? Um, I know that if I flip 1/5, I get to 5. So I feel like we're going to have a negative power because I need to flip 1/5 in order to get to 5. Um, and then have to maybe cube it. So maybe you can see that it's going to be -3. It is going to be -3. Another way to kind of look at this one is rewrite both sides with the same base. So, and kind of make it a little equation. Rewrite each side with the same base. And what I mean by that is that this is 5 to the -1, and then we have like a question mark, power or x. And then this side is 5 cubed, right? -1/5 is 5 to the -1, but then we have our question mark, so I put an x there, like we have to solve for x. Here we have 125, which is 5 cubed. So because we have 5 to a power and 5 to a power, we can really take these powers and set them equal. So -1x equals 3. And if we divide by -1, x equals -3. So that's a way to get this. If you don't see it visually, but need to set up a little equation, you rewrite each side of the equation with the same base, that they're both 5 to something. And then we have that x or that question mark needing to be something. So the next one is kind of similar. I start out, 25 to what power is going to be 125? And maybe I don't know, like, what is that question mark? But I recognize that 25 and 125 both are 5 to something power. So this one is 5 squared. 25 is 5 squared. And I'm going to put an x there because the question mark is there. 125 is 5 cubed. Okay, so if I can see that, then I can set these parts equal. So I'm going to have 2x equals 3. That's only if they're the same base. If they're a base of 5, that's how I can do that. So if I divide by 2 here, I get x equals 3/2 or 1.5, but x equals 3/2. So we're saying the log base 25 of 125 equals 3/2. 25 to the 3/2 power equals 125. All right, number 12, we have log base 7 of 1. So we're saying 7 to what power equals 1? Remember, this was one of those rules we had at the bottom of the page. 7 to the 0 power equals 1. So log base 7 of 1, log base anything of 1 is 0. Number 13, 12 to what power equals 12 to the x? This is kind of, it says log base 12 of 12 to the x. It has an x in the equation, which is a little bit weird, but that means we'll probably have an x in our answer. So if I have 12 to what power equals 12 to the x, well, we kind of see question mark equals x. Like x is our answer there. Question mark, the thing that I'm trying to solve for is x. Number 14, 3 to what power is 27 to the x? Saying 3 to what power is 27 to the x? So we have a question mark and this x. It's not as easy as that, the one we just did. What I'm going to do with this one is kind of say 3 to the question mark equals 3 cubed. I'm going to rewrite that 27 with the same base. So I kind of have question mark equals 3x, kind of like we had up here. But it's weird because I have question mark and x. I'm saying question mark equals 3x. So 3x is my answer. And the reason we're going to put these X's in there, we don't just do it for fun, but we do it so that it's not like you can't put it in your calculator. Like you have to actually know things, because I will eventually show you how to do these in your calculator. But the ones with the X will be on the quiz, will be on the test, because you can't use your calculator. All right, last one, number 15. I have 1/2 to what power equals 16 to the 2x. This one looks pretty intense. 1/2 to what power equals 16 to the 2x. And just like we did up on the top, we want to rewrite both things to the same base. So this one is 2 to the -1 times question mark, because 1/2 is really 2 to the -1st power. 16 is 2 to the 4th. And then I still have the 2x there. Okay, so I end up with -1 times question mark, weird thing there, question mark, equals 8x. So if I'm trying to solve for question mark, if I'm trying to get question mark, like that's what I want to know, I divide by -1. And so I get like question mark equals -8x. And so really, -8x is the answer to like the problem they're asking. They're saying, 1/2 to what power is going to give me 16 to the 2x power. And so it's really, 1/2 to the -8x power is the same as 16 to the 2x power. Because 1/2 to the -8, ooh, that's big, but let's do it. I'm just going to plug that in my calculator. 1/2 raised to the -8 is really 256. And then we still have the x there. And 16 squared is also 256. So when we're trying to solve like what is question mark, we're saying what value of this, exponent is going to get what we want. And it's -8x gets us there. Okay. So today's just starting logarithms. We want to be able to rewrite things from on that first page. rewrite from exponential form to logarithmic or from logarithmic to exponential. So really understanding how just the different parts go together. And then they're also going to ask you some questions like this, where they give it to you as a logarithm, log base 4 of 64. And you need to be able to think, okay, 4 to what power? And I think it's helpful, write it out as an exponent so you can like see it. 4 to what power equals 64. Some people, instead of question mark, just because you feel weird about it, you say 4 to the p power equals 64. And p has to be 3. If you feel better about a p than a question mark, that's fine too.